Okay, let's discuss the breakfast search algorithm with the dry running of an algorithm. Now we're going to look at this. We're going to look at this tree structure where we have a node to start with, and then we have its descendant or child nodes, and so on. Okay. Now this is the algorithm that we are going to discuss, and um, the function is for breadth first search. It begins with the start node. In our case, it's a node. Now, open here is referring to a list that is maintained as a queue, and the closed states already visited nodes. All the nodes which will already be visited will be placed in this list. Okay, and the first thing we would check in this algorithm is where to check whether if there are any um, nodes which are open, i.e., which still needs exploring. Okay, so how we start with, we're going to take the leftmost state from open, and we'll call it x. And if our current node x is the goal node, then bingo, we got success. That was the state of integration we were trying to find out. Otherwise, we will generate the children of this current node, put x on closed. It means this current node which we already visited will be placed in the list closed, and we're going to discard all children of x if already on open or closed. If any children or nodes which are already on our list of open or closed, then we don't need to um, put them in or explore them. Okay, rest of the children we will put on the right end of the open list. Okay, and if we couldn't find our goal node, the function will return fail. Okay, now let's run this algorithm and see how it goes. Okay, right, let's start. Can I get the pen? Right. The very first thing we will try to do is to get the dry running. So I'm going to put all the possible options there. For example, open is going to get me the lists for open nodes. Closed, X, and we will have another one which is children of X. Okay, I think that will do. Let's specify our goal node, okay, as F. So if we traverse this algorithm and we find F, then it means we have found our desired node. Right. When we start the algorithm, the very first thing that happens is that the uh, start node is placed in open. Okay. At this point in time, the closed is an empty set or list, and now we will check the very first thing we check in our algorithm about whether open is empty. In this case, we already got our start node, so it's not empty. So we're going to go into the loop, and we're going to remove a uh, from our list from open, and we'll put in x, okay, which is like a temporary location to hold our nodes or current state. So we're gonna put a in x there. Now, um, if now we're gonna check if x is the goal, then we return success. It means we have found our goal. But If it is not, then we will look at all children of x. We generate the children of x. Let's, in our case, the children of x are B, C, and D. Okay. Okay. Um, and what we do, we will put x, which is A, on closed. So we added A in the list for closed. Now we're going to discard the children of x if already on open or closed. So B, C, and D are already they're not on open or closed in open or closed lists. So it doesn't matter. It doesn't. It's not applicable here. And so what we need to do then, we need to put the children on any remaining children, i.e. all of them in this case, on the right end to open. So what we need to do, we need to put these children in list open, B, C, and D. Okay. Right. So at the end of the first iteration, we have open list which is looking as B, C, D, and closed as A. Right. So, and we will go back to the start of our loop, and we will look at we'll check the condition again whether the open is empty. Is not, we got like three nodes here, B, C, and D. So what we need to do, we need to remove the leftmost state from the open. So we're going to remove B from here and put that into X. Okay. And then we check if X is the goal node. Is it the goal node? In this case, it's not. So we're going to generate children of X. In this case, the children of X are E and F. Okay. Right. And then we'll put X on close. So we'll change X and put it on closed. In this case, here. Okay. Update the closed list. Okay. After that, we need to look at any children of X if they're already on open or closed list. E and F are not on open or closed. So what we need to do, we need to put these children on the right side, right end of the open. So this is going to be um, C, D, E, and F. Okay, and this is where our loop will end. So we're going to check again whether open is empty or not. It's not. So what we're going to do, we're going to remove the leftmost state from open and call it X. In this case, we put it in it's C, so we place under X. Now we're going to check the children of X, generate children of X. For C, the children are G and H. Okay. And we repeat the same process. We will put X on close. In this case, we will put here, which is C, B, and A. And the next step is to discard all the children, which if they are already on open or closed list, G and H are not, so it's not applicable here. We put these G and H, these children of C, at the right end of the open. So that will be D, E, F, G, and H. Okay, so right now we again at the end of the list and end of our loop. We'll check again whether open is empty. It is not, so we are going to um, take the leftmost element uh, from our open list and put it in X, which is here, which is D, and we're going to generate the children of D. In this case, they are I and J. Now we'll check again, I and J, are they open or closed? They're not, so we need to put um, I and J in on the right side of our open list. Okay, and the D will be removed and placed in the closed section here. Just there actually. C, B, A. It will be actually D. So let me just get rid of that. Okay, let me just try it again. So what we need to do, we need to put D, C, B, A. So that is the state of our closed at the moment. Okay, now we are again at the end of our loop, and what we need to do, we need to check the leftmost element in our open, um, put it on X here, and generate the children of E, which would be K, K, and L. Okay, so we will put E on closed. In this case, it will be E, D, C, B, and A, and then we will put the children R, K, and L at the right side of open state, open set. F, G, H, I, J, K, L. Okay. Now the next iteration, and we'll check again whether open is empty. It's not. So what we need to do, we need to take the leftmost side element from the open set, put it as X, and we're gonna check whether this X is um, the goal. In this case, it is. So it's a success. And the algorithm will return a success here, and it will terminate here. Okay. Okay, so congratulations. Now we have actually managed to run through the algorithm. If now if you see, here we started with A, and that goes to B, and C, and D, and then E, and finally we found our goal. So that is we um, know the path through the closed set A, B, C, D, and E, and finally F. Okay, the two things I like to mention before we close this web course is basically the your open. Okay, it's a list to set, lists, states that have been generated but whose children have not been examined. Um, so that's open. The close records states already visited. Okay, so that will conclude our section here, and I will discuss rest of the algorithms with you shortly.